7-7 in Advanced Algebra 2, you get a nice little story to start us off with. We know that symbol right there is pi, and you should know by now that that is really a number, right? It is a number that the mathematicians, the Greeks, and all those people way back in the day figured out is really the ratio of the circumference to the diameter of the circle, right? They figured it out. It is a nasty, irrational number, so they made up a symbol for it instead. Well, there were some really smart mathematicians by the name of Leonard Euler and John Napier. Euler, I know it looks weird, but it's pronounced Euler. He's the guy that's really credited with coming up with another weird symbol called E. E is like a natural number, something that occurs often in nature. This old boy, Euler, did tons and tons and tons of experiments. And he figured out that this number, 2.71828, blah, 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 just kept showing up naturally in these real-life problems. Just like that weird number of 3.14159, you're like, oh, that's a weird number, Here's this other weird number. Since it was irrational, he came up with the symbol of E for it. Well, that's the base in our natural logarithms. If I wrote this, what is the base in that situation? This is a common logarithm because it's base 10. Well, since E happened so stinking naturally, they said, hey, man, and it's an exponential situation most of the time, it's like, why don't we come up with a whole new logarithm that has E for the base normally? So they didn't want to write log base E of 5 or anything like that. They just said, why don't we call it a natural log, right? Like a natural logarithm. Since E is such a natural number, they just say ln, where the N stands for natural and the L stands for logarithm, right? So ln. And you can even see that that's right below your logarithm button on your calculator. Isn't there an ln button, correct? Look right above the ln button as a second function. What does it say right there? E to the x, right? E is on your calculator. So if you wanted to figure out what E actually is, let's hit second E, right? You have to hit that natural log. And it always puts an exponent to you because that's what you use E for. You got to take it to a power. Well, how do I figure out what E is? What power would I have to raise it to figure out what E is? To the first power. That 2.7182, meow, 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 meow. There's that number right there. It's the number E. So realize whenever we have an E in our problems, we don't want to use regular common logarithms. We would much rather use natural logarithms. Okay? So let's dive into some problems right here. Evaluate these logarithms to the nearest 10,000. Well, natural log has base E every time. Do we have a natural log button on our calculator? Yes, we do. So we can punch this straight into our calculator, if you give me a second here. Natural log of 12,492. Rounder to the nearest 10,000th. About 9.48. Groovy? On the next one, people are like, hey, should you condense those logs if you want to? They're still logs, right? And a lot of times you'll actually hear me say it as log, and I apologize because once you get further in mathematics, you kind of never use the LOG. You always use natural logs. So I might actually accidentally call this log, but we'll call it natural log. Cool. But do I need to divide the arguments? You can if you want to, right? You could say, well, I'll take the natural log of 493 divided by 181, but why not just punch natural log of 943, close the argument, minus natural log of 181. Either which way, since they're equivalent, should get you the same answer. So that is about 1.65006, right? Try the rest of them. Punch them all in. So here's what we should have got on all these bad boys. Check yourself before you wreck yourself. All the same rules of logarithms apply. It says write a logarithmic equation equivalent to the following. So this is exponential, correct? Isn't the x up in the exponent? They want us to write it as a logarithm. But my friends, what's the base of these problems? E. So don't use log, log. Use natural log instead. So the natural log of the argument, what's the argument? 7 equals the exponent, which is 2x. And notice you don't want to put this right there. It's understood that e is the base when you use natural log, so don't have it, right? If you had to write it the other way, it has to be this. These are the same stinking thing, but this is very immature mathematically because they created an entire word called natural log to stand for this, of log base e. So how about this bad boy right here? Since e is the base, it's the natural log of the argument, which is what? 10x equals the exponent of 8.2. We're not solving for x. All they asked us to do was rewrite them, going back to square one with our logarithms, except these are now natural logs. Then they say write these in exponential form. They used an approximate symbol, so we'll use an approximate symbol. So we want to write it in exponential form. What's the base? E is the base. What's the exponent? It's this 0.3345. And then since they use an approximate, I'll use an approximate of the argument right there. Give number 10 a try real quick. Rewriting it exponentially. Yeah, e to the x equals 42. Cool. Awesome. Your turn. All 6 of them, right? Do what they tell you. Write an equivalent exponential or logarithmic equation. Get all 6 of them done. If they give it to you exponential, rewrite it logarithmic. If they give it to you logarithmic, rewrite it exponential. Same thing we just did. You can check yourself out there in video land. That's what these puppies are supposed to be. Now, let's continue. Simplify these. Same basic rules of logarithms. Aren't they subtracting this situation, right? And you got a number in front of a natural log. Doesn't he come up as the exponent right there? So I'm going to do a 2 for 1 special. 10 to the third is 1,000, right? And the natural log has not disappeared yet. Minus natural log of 8. Cool. Now, since they have subtraction going on, I will take 1,000 divided by 8. 125, right? So the natural log of 125 is what that is. And then you got to ask yourself, can that clean up? Is e to any power turn out to be 125? No. The things that'll clean up nice is if this has an e with it still. Right, so I kind of skipped over that at the beginning. Let's go over that at the beginning. Oh, I cut that out. So, like, what do you think the natural log of e would be? Remember, if you're not sure, you got to rewrite it. Let's call that x, and isn't this really the base right there? E to the x equals e. What does e have to equal? Or, sorry, what does x have to equal? 1. Isn't the natural log of e turn out to be 1? Y'all cool with that? What about if I did stuff like this? All right. Well, we could go back and rewrite it exponentially. E to the x power equals e to the second power. What does x have to equal? 2, right? The ones that are non-calculator, if it's natural log, there will be an e involved in the argument somewhere. You know that? Cool. All right, next one. Natural logs again. Let's do some condensing. First of all, this is natural log of, here's how I'll do it. I need to do what with all of these arguments when we're adding them together? Multiply them together. So watch this. I'm just going to take that 40 and take it times. Doesn't this need to come up right here? So if I can do that mentally, I will. If I don't know that mentally, I'll write it out. But 1/2 squared is how much? 1/4. And here's a whole other argument right here. Doesn't it need to be multiplied together also? I just kind of made it simple for myself. I knew I have to multiply all the arguments. Well, I want to see them all before I multiply them. Cool? 40 times 1/4 is how much? 10, and there's an x with it also. That's really the natural log of 10x, because you had to take the argument of 40 times this argument, which is really a 1/4 because the squared happened, times the x. Yep. The question was asked, how come we still have a natural log in this when all of these terms have a natural log with them? This is not an equation, is why. We're not solving for anything. We dropped the logarithms. Like if I had natural log of 7 equals natural log of 3, do you see how there is an equation involved with here? I should put an x there, sorry. Natural log of x right there, you know? Do you see how this is an equation? If there is an equation with every term that has a logarithm in it, you can solve for the missing by saying, well, I can get rid of the logarithms and say x has to equal 7. You can't solve for x in this situation because it's not even an equation in the first place. You're just simplifying it. Cool? Next one. This is really natural log of 25. Now, do you see how we got addition and subtraction in the same deal? So that note tells me I need a fraction, right? Where's the 25 go? Up or down? Up. Then plus this 2 to the 4th, which is really 16, right? If you want to just kind of sketch that out right there, this is really 16, 2 to the 4th. Where's that got to go? Up or down? And shouldn't it be multiplied in there also, right? Minus, so that means that this argument goes downstairs. Cool? And then there's one other thing that needs to be in there. He's going downstairs, right? And what goes downstairs? 3x or x cubed? X cubed. You all comfy with that? Yep. All right. So now we got to clean some of this up. You could multiply 25 times 16 if you wanted to first, but I can see something that I can reduce right away. Do you know what 25 over 5 would reduce to? 5 over 1. So doesn't that become a 5 and that becomes a 1 right there? Now I'm just going to take 5 times 16. The natural log has not disappeared because this is not an equation. This is just an expression. And you've got 5 times 16, which is 80. Is that right? Over, I'm a fan of putting x first and y second, but if you had y times x cubed, it wouldn't hurt my feelings. But I like to put them in alphabetical order. One more, baby. You and pal, get that puppy done. What I did is above this problem. I just kind of figured out what all these arguments really are. I brought the 7 up and called that x squared. I brought the 2 up and called that y squared. That's a z. I brought the 3 up and 5 to the 3rd is 125. Then I put them all in the right place based on what sign was in front of them. Feeling good with those? Yeah? All right. Solving. Same thing as before. Talk yourself through it. There are logarithms involved in this equation, correct? Does every term have a logarithm with it? Too many of you are sleeping on me. This has a logarithm with it. Does every term have a logarithm in it? Nope. So our idea is to get it to be log equals number. There's things you can do with this 3. You could bring him up here, but you could get rid of him a whole lot easier because isn't this a times 3 in front of the log? How could you get rid of that times 3? If we divide both sides by 3, this would be the natural log of 4x equals 24 divided by 3 is how much? 8. All I did was get rid of that times 3 in front because it was one log, right? That's just one term right there. It wasn't like a log plus another log or anything that needed to be condensed first. I got rid of that times 3. Now, it's log equals number. How do we deal with these? What did you do when they were LOGs instead of LNs? What did you do? You can't drop the logs. Why can't you drop the logs? There's not logs on both sides. Where's the x at? Is it in the argument or is it upstairs? It's in the argument, right? There's a way to get the argument all by itself, though, is to do what? Rewrite it exponentially. What's the base? E is the base. right? E is the base because it's a natural log. What's the exponent, baby? 8. That should equal 4x. You see, that's how you get the argument by itself. When there's a logarithm, you need to rewrite it exponentially. Is x all by itself before we go further? Nope. What would you need to do to get x all by itself? So x equals e to the 8th over 4, baby. Right? That's the exact answer. It says that up here. Find exact answers and answers rounded to the nearest 10,000. There it is exactly. Now, let's figure it out. E to the 8th divided by 4. E is located above the natural log button, so e to the 8th. Close that parenthesis because it'll automatically put it there for you. That's the whole numerator, correct? Divided by 4. Let me look. So let's round that to the nearest 10,000th, and x would be about 745.2395. Gribby? You with me on that? See how I just kind of kept it on one line? Let's check it. Where do we substitute it back in at? To the original? I got a question for you. Do I know if this is even possible in the first place? Isn't this in the argument right there? Did I get a positive number back? So it's possible. It's not extraneous. If you got a negative number back, you did something wrong. Cool? Let's type it in just as 3 times the natural log of, do you see how it automatically put a parenthesis for your argument? 4 times that previous answer, close it up, right? Isn't that argument 4x? Right? Now, they didn't have parentheses in the original problem, but it's understood that that's really in parentheses there. You should get back 24, which we did, so check it. Cute? Next. Where's x at? In the exponent. That means we want to get e to whatever the heck that is all by itself. What would you do first to get that all by itself? Add 5 to both sides. So 4e to the negative 2x equals 8. Rock and roll. Divide by 4. E to the negative 2x equals 2. Now that e is all by itself, right, and x is upstairs in the exponent, there's only one way to bring him down. How do you bring him down? We need to log both sides. Now, what kind of log would you choose if e is the base? Regular or natural? So let's natural log both sides, okay? Or you could rewrite this logarithmically, right? You could natural log both sides if you want to, but it's going to be a lot more work. Isn't e the base? And you know those first few 10, 15 problems that we did where here it is exponentially, please rewrite it logarithmically? It's going to be the natural log of, what's the argument? 2 equals the exponent, which is negative 2x. And I guarantee you, if you would have natural logged both sides, which I'll do off to the side, wouldn't negative 2x come in front? You'd natural log this, and that would equal natural log of this, right? But see this right there? That's the number 1. Isn't the natural log of e really 1? Because it's e to what power gives you e, right? It's 1. So that's what ends up happening. I'm saying if e is the base, just go back to very basic logarithmic skills and rewrite it logarithmically. Cool? Now, let's solve for x. What do you got to do to solve for x? Divide by negative 2. See if you can punch it in correctly without me showing you. Get your numerator in there and make sure you closed all your arguments. There's only one term in the numerator and one term in the denominator. That's the exact answer. I'm going to get it approximately negative 0.3466. And then I'm going to check it. So to check it, I go back in and I'm going to retype the original Broham. I want to just type this left side in and see if I get 3 back when I hit equals. So 4 times e to the negative 2x. Well, wherever there's an x, that's where that previous answer goes. then either get out of that box that you have on your calculator or close your parentheses, one of the two, right, depending on how your calculator is. Still got to do something. What do you got to do? Minus 5, hit equals, you better get 3 back. We got 3 back. Cool. Try again. What would you do, baby? What would you do? Does every term have a log with it? There are logs involved. Does every term have a log with it? Nope. Get it to log equals number. How do you get rid of that 2 in front of there? So natural log of 5x equals 3. Groovy? Now that it's log equals number, do what? Rewrite it exponentially. Go for it. Rewrite it exponentially. Should get that. Then solve for x. Punch her in. We're cool with about 4.0171-ish. Let's check him. 2 natural logs of 5 times that previous answer. Close that up. I hope I get 6 back. Yay, I got 6 back. Rock and roll. Next. Is this logarithmic or exponential? Exponential. Isolate this. Isolate that before you do anything. Isolate that. Right? E to the 2x equals 8/3. Yeah, it's a fraction. Who cares? E to the whatever is by itself. How do you bring that stuff down? Now that x is in the exponent, how do we bring it down? We would log both sides normally, but since the base is e, you could also do this if the base was 10 with common logs. You can just go straight to that logarithmic form. Since the base is e, it's going to be a natural log of the argument, which is what in this case? And that will equal 2x. Cool? And then x equals natural log of 8/3 all over 2. Parentheses are important. Make sure you get 8 typed into your argument correctly. Natural log of 8/3 divided by 2. Natural log of 8/3 divided by 2. Boom. About 0.4904. Check it. Three times e to the 2 answer. Close that up. Plus 2. 10, baby. 10. Yay for me. Try das next one. Well, tell me what you do first, since this is a little different. What's the first move that you got to do? Condense these logs, right? Condense the logs. Ruby, condense the logs. Because there's logs involved, but there's not a log in every term. Regardless, you have to condense the logs. You know that you should multiply those arguments together. I hope you can take 5x times 3x without my help. Keep going. Keep going. Talk with pal. So what's the base? E to the equals 15x squared. Cool. And if you'd talk yourself through it, you'd be pretty good at solving for x. Yeah, it's x squared, but what should we do first? what do you want to do first? Divide by 15 first. E to the 9th equals 15, or excuse me, e to the 9th over 15 equals x squared. Rock and roll? Now that x squared is by himself, what do you do? X equals plus or minus the square root of e to the 9th over 15. Notice the plus or minus. Two answers. Cool? Let's be super smart. Where's x located? Argument. What do you think about this negative answer? Do you think he's going to work? No way, because we've got, so I'm just crossing that out. Ms. Colwell simplified her radical. She split it up, rationalized it, got rid of all that. I'm cool with this, right? Punch this in your calculator. But realize that this is not the exact answer because you have a fraction underneath the radical. You should split it up, etc. But I want the square root of e to the 9th divided by 15, close it up. I got about 23.2423. Remember, we threw the negative 1 away because we saw it already that it's not going to work, right? The x is in the argument. You can't have that negative number back in there. Let's check it. Natural log of 5 times x, which is your previous answer, close the argument, plus natural log of 3 times x, close the argument. If I hit equals, I hope I get 9. I did.
Now, just a few quick story problems here. When Angelina was born, her grandparents deposited $3,000 into a college savings account that pays 4% interest compounded, boom, continuously. So that means we'll be using PERT. Assuming there are no deposits or withdrawals from the account, what will the balance be in 10 years? So, of course, we can start with the formula for PERT, and here's what we know. We know the starting amount is $3,000, so that's the principal. We know the rate is 0.04, and we know the time, so we just substitute those three things in right there. Bada boom. And what we're looking for is A, which is all by itself on one side of the equal sign. So we just straight up punch that in. Like, this is just way too easy. We've kind of done some problems like this before. So 0.04 times 10. Bob, boom, and since it's how much money they'll have in the account, we'll just round it to 2 decimal places. So I got me $4,475.47. Part A, no big deal. No logarithms needed either, because what we were looking for was already like by itself on one side of the equal sign. And how about part B? To the nearest tenth of a year, how long will it take for the balance to reach at least $10,000? Well, it's still a PERT situation, so we'll start with that. Amount equals PERT. And here's what we can sub in. $10,000 is the amount we will have when we're all said and done, because that's what she wants to have. The principal is still the same. It's the $3,000. E is still there. It's the same bank, so same 4%. But see, we don't know how long, so that's why we're looking for T. And, yep, you guessed it. Due to the fact that T is up in the exponent, what we're going to need to do is solve with logarithms. But here's the part that's hard for a lot of people is they want to start logging both sides now. We can't do that because the base, which is E, the base is the guy that's who's being raised to the exponent, is not all by himself on one side of the equal sign. There's this times 3,000 in front of it. So we got to get rid of that. And the way we'll get rid of it is we'll divide both sides by 3,000. So if I do this, which you don't have to show the baby steps like this, just kind of showing you what I did. This 10,000 over 3,000, that reduces, like all those zeros end up canceling out. It just becomes 10 over 3. And then we finally got this base all by itself. So now this is where we want to log both sides. And we got to choose between the common log or the natural log. Since E is involved, we are totally going to natural log both sides. So I got the natural log of 10/3 equaling. The exponent comes down in front. That's why we are logging both sides. And you got the natural log of E right here, which is awesome because the natural log of e is really the number 1, so we can cancel him out. Like natural log of e, remember it's just like, remember there is a base of e there. It's like e to what power is e? Well, that's 1, so that cleans up real nice. So that's why we wanted to natural log both sides. And then to solve for t, we're just going to divide both sides by 0.04. So let me kind of go back. So we'll divide both sides by 0.04, and t is going to be the natural log of 10/3 divided by 0.04. And to punch that in, we got to be real careful how we punch that in. So I need to use the natural log of 10/3. Remember, it automatically starts that parenthesis for me, so I got to close it, and then I could divide that by my 0.04. And they say round that to the nearest tenth of a year, so it would take about 30.1 years for that to happen in that case. So don't forget to label the times, about 30.1 years. Then if her grandparents wanted to have $10,000 after 18 years, how much would they need to invest? So that's a good question. We'll start with PERT because it's a continuous situation. They want 10,000 when they're all done, so 10,000 is going in for A. See, I don't know the principal. They don't know how much they want to invest, so that's still going to be P. E is still there. The rate's still 4%, and they want it for 18 years. So this is cool. Check out who we're trying to solve for. We're trying to solve for P, which is not up in the exponent. He's down on the normal level where we like him. All we got to do is get rid of this. And this is a times e to the weird exponent right here. We're going to get rid of that by, first we're going to clean up what the heck that exponent is. What is 0.04 times 18? Well, that is 0.72, if I move that over a little bit. So, okay, got that guy right there. So 0.7, went the wrong way, sorry. 0.72 is what this cleans up to be. And then all we got to do is divide both sides by e to the 0.72. So our P will equal 10,000 divided by e to the 0.72. Like, see how this was a times e to the 0.72? I'm going to divide. So I'm going to punch it in. 10,000 divided by e, I've always got to hit second for that, to the 0.72. And that's what I got. So I'll round that up because they need to have a little bit more money to invest. So $4,867.53 is what her grandparents have to invest. This is what their financial planner would say to them. It's like, yeah, you need to put this much money in. So they'd probably in real life go, okay, here's $5,000, you know, whatever. But this is what the math says. And I think that's enough for today. We're not going to do part D. There's nothing different about it, but I just said, that's enough. So, hey, let us know if you have any questions, especially with these story problems. We're happy to help, and have a good one.